In this video, we will have an introduction to the topic of complex numbers, iota and the powers of iota. So to begin with, what are complex numbers? We know that number systems, the first set of numbers are the counting numbers. The counting numbers are called the natural numbers, which begin from 1, 2, 3, 4, 5, 6 to positive infinite is the set of counting numbers, which is otherwise known as natural numbers. Natural numbers is encompassed by another set of numbers called whole numbers. Whole numbers begin from 0 and the set of natural numbers make the set of whole numbers. 0, 1, 2, 3, 4, 5, 6 to positive infinite is the set of whole numbers. The set of whole numbers is encompassed in the set of integers. What are integers? Integers consist of 0, the positive natural numbers means positive numbers, counting numbers, and the negative counting numbers means integer consists of 0, 1, 2, 3, 4, 5, 6 to plus infinite and minus 1, minus 2, minus 3, minus 4 to minus infinite or negative infinite. So set of natural numbers are embedded in the set of whole numbers. Set of whole numbers is embedded in the set of integers. Zahlan, this is Z symbol form. Set of integers is embedded in the set of rational numbers. What are rational numbers? Rational numbers are represented in form of a fraction p by q, where the denominator q should not be 0 and p and q are any integers but denominator q should not be 0. So natural numbers are embedded in set of whole numbers. Whole numbers are included in the set of integers. Integers are included in the set of rational numbers, means every integer can be represented in p by q form, but the p by q form condition is p and q, both of them are integers but denominator q should not be 0. Then there is that is rational numbers. Then there is another set of numbers called the irrational numbers. What are irrational numbers? Irrational numbers are all those numbers which cannot be expressed in form of a p by q, where p and q are integers and the denominator should not be 0. So all those numbers whose decimal representation is non-terminating and non-recurring, means kind of irrational way of proceeding in the decimal representation. So number system consists of natural numbers, counting numbers, natural numbers, whole numbers, integers, rational numbers, and another set of numbers called irrational numbers. Rationals are quite rational. Rational numbers, a decimal representation is either a terminating decimal or a non-terminating but recurring decimal. Irrational numbers cannot be expressed in form of p by q, where p and q should be integers and denominator should not be 0. Its a decimal representation is non-terminating and non-recurring, means we cannot guess also where it is going to end, will it end or not, and what set of numbers are going to come after the decimal after a certain set of numbers. The set of rational numbers and set of irrational numbers are encompassed in the set of real numbers. What are real numbers? Real numbers are all the numbers that really exist. That means rational numbers, irrational numbers do exist. We have seen numbers in form of p by q, means say 3 by 4. This number really exists. But we have not seen a number like 3 by 0. This is quite not defined. So we don't talk about 3 by 0. So rational numbers are anything that is represented in 3 by 4 p by q form. Denominator should not be 0. So set of integers, whole numbers, natural numbers can be written in form of p by q. Set of irrational numbers cannot be represented in form of p by q, where p and q are integers, they are co-primes and denominator is not 0. Every irrational number is either in form of square root of a number or cube root or some nth root of a positive number. So this is the set of real numbers. Real numbers are those numbers which we really often face or encounter. Other than real numbers, there is a world of imaginary numbers. What are imaginary numbers? Imaginary numbers are those numbers which or whose values are in our imagination. The set of real numbers, set of imaginary numbers are contained in the set of complex numbers. So here we introduce ourselves to the complex numbers. What are complex numbers? Complex numbers are the combination of real numbers and imaginary numbers. Complex numbers are represented by a letter Z, but it's not compulsory. It can be taken like we can represent complex numbers as Z, which consist of its real part as well as its imaginary part. Real part is any of these kind of numbers. So we can take any of these numbers as sum A, and the imaginary part is a sum B. But this part is imaginary. So to this we will attach an I symbol just to tell that I is for imaginary, an iota of thought, times B. So every complex number is represented in form of A plus IB, where A is a real number, B is also a real number, but real number multiplied to imaginary number becomes, or real number multiplied to I becomes the imaginary part of the complex number. So every complex number is represented in form of A plus IB. So that was the Venn diagram introduction to a complex number. This one is the flowchart introduction to the complex number. A complex number has two components, the real number part and the imaginary number part. Real numbers are made up of rational numbers and irrational numbers. What are rational numbers? Rational numbers are all those numbers which can be represented in form of P by Q, where P and Q belongs to the set of integers. Integers are those numbers which consist of 0 and positive natural numbers and negative counting numbers. Here P and Q are co-primes. Co-primes meaning is they need not be prime numbers, but they have no factor in common, and the denominator Q should not be 0. What happens if denominator Q turns 0? Then this number appears in form of P by 0. A number by 0 is not defined, whereas 0 by a number is a rational number, to tell that 0 is also a rational number. What are irrational numbers? All those numbers which cannot be written in form of or cannot be expressed in form of P by Q, with P and Q following these instructions. Decimal representation of an irrational number is a non-terminating and non-recurring. Examples of irrational numbers is any number that is written in form of square root or cube root or fourth root or some nth root of any positive number. The positive number can be a decimal number, a fraction, but whatever. The number should be a positive number. Every irrational number is written in this form. So complex number is made up of real number. Real number can be in this form or in this form, plus the imaginary number. What are imaginary numbers? Imaginary numbers are represented by the letter I. And what or how do we read I? I stands for the imaginary component of the complex number, but it is called the iota. Now we will know what is iota, or where are we going to get this iota during our calculations. Consider the following quadratic equations. The first one, x square plus 3x plus 2 equal to 0. Another, x square plus x plus 1 equal to 0. The first one, we are able to do the splitting middle term, we are able to factorize. So on splitting middle term, what's the process of splitting middle term? 2 into 1, 2. So 2 and 1 we have to write such that their sum is a 3 and product is 2 into 1, that is 2. So obviously the numbers are 2 and 1. This on factorizing, we will get x plus 2 times x plus 1 is 0. Either this factor is 0 or this factor is 0, and we will get x as negative 2 or negative 1. How does the graph looks like when we plot or when we draw the graph for this? This equal to y when we do. For various values of x, we will get the corresponding value for y, and those values we can plot in this Cartesian plane to get the graph of this. When we draw the graph for this, the graph is a parabola. Why? Because it's quadratic. Quadratic equations graphs are parabolic in nature. Where this graph intersects the x-axis, those are the zeros. So this equation's graph is going to intersect the x-axis in these 2 points, and the graph is going to be in this form. So these are the 2 zeros, which is minus 2, negative 2, negative 1 belong to the set of real numbers. That means this quadratic equation has real roots. What about this? Splitting middle term, it's difficult to think, so let's use the quadratic formula. Quadratic formula, this is ax square plus bx plus c. So a is 1, b is also 1, c is also 1. So x is minus b plus or minus root over of b square minus 4 times a into c by twice a. Here x is negative 1 plus or minus root over of negative 3 by twice a. Root negative 3, we do not know where this point lies. We know where is negative 3, but root negative 3 is not known. During the discussion of quadratic equation concept, we must have learnt that when discriminant, that is b square minus 4ac. In this case, 1 square minus 4 times 1 into 1, which is 1 minus 4, which is negative 3. When discriminant is a negative number, means less than 0, then we declare that the quadratic equation has no real roots. No real roots meaning is, when we draw graph of this equation equal to y, we assume various values of x, like x as 0 first, then y will be 1. X square plus x plus 1 is a y. When we want to draw graph of a quadratic equation, we have to write the quadratic equation equal to y, not 0. And then we can have a table like this, where when x is 0, y is 1. When x is a negative 1, so this is negative 1, this is negative 1 square, so positive 1, these two cancel. So y is a once again 1. When x is a 1, so this is a 1 plus 1 plus 1, so y is a 3. Okay, I just verified this. Yeah, that's true. So these are coordinates x comma y, x comma y, and x comma y. This, when we plot these points, when we plot in the Cartesian plane, how the graph looks like. The graph is 0, 1, negative 1, 1, 2, 3. 0, 1. 0 of x-axis means search nothing on x-axis, go to 1 of y-axis. So this coordinate is 0, 1. Then negative 1 of x-axis, positive 1 of y-axis. So here this point, and 1 of x-axis and 3 of y-axis. So something, and here maybe we get some other points also. The graph appears like this. So this is the parabolic graph. Graph will be parabola. Why? Because the given quadratic equation, is quadratic. If degree is a 2, the graph is going to be parabolic, and x square coefficient is a positive number, so this graph opens upward. And you see, this parabola did not intersect x-axis at any point. Means x-axis is this number line consists of a set of real numbers, and there is no real number to which this graph is connecting. So there is no real value of x, so no real roots. If there is no real root of an equation, then definitely the quadratic equation has imaginary roots. Now we will know What is the meaning of imaginary root in this case? The number that we just now got was under radical negative 3. Due to its presence, we declared x square plus x plus 1 equal to 0, having no real root, means imaginary root. How to write this? This can be written as root over of negative 1 times 3. Root over of a into b is root a times root b, and a is a negative 1 and b is a 3. So we can write this as root over of negative 1 times root over of 3. Root 3, we know the value is 1.732, fine, but root of 1 is 1, but root of negative 1 is not known. So root of negative 1, we represent this by a symbol called I, means imaginary part of a number, and we call it as iota. So root over of means a square root of negative 3. Square root of negative 3 is I times root 3, I root 3. Therefore, square root of negative 1 is I stands for iota, and once we square on both sides, we will get negative 1 is equal to I square. So we will remember that I square is a negative 1, and now we will see the powers of iota. Since just now we saw root over of negative 1 is iota, on squaring both sides we are getting I square as a negative 1. First we will find the positive powers of iota, means I raised to the power positive index number. Then we will go for I raised to the power negative index number or negative exponent. So first I square is negative 1. What about I cube? I cube can be written as I square times I. Since I square is negative 1, so negative 1 times I is a negative I. So I cube is negative I. Then I to the power 4. I to the power 4 can be written as I square times I square. I square is negative 1, so we will write here as negative 1 times negative 1. Minus of minus is a plus, 1 into 1 is 1, so it is positive 1. Then I to the power 5. I to the power 5 is I cube into I square. I cube times I square. I cube is negative I square is negative 1. Negative of negative is positive. I into 1 is I. So we saw that I square is negative 1, I cube is negative I to the power 4 is 1, I to the power 5 is 1, I. You see some symmetry here. I square negative 1, I cube negative I to the power 4 is a positive 1, and I to the power 5 is a positive I. So we will just test for I6 and just check that whether this cycle is repeating or not. Means minus 1, minus I, 1, I. If here we get minus 1 and then I to the power 7 we get minus I, its meaning would be I square onwards, every next exponent of iota is in form of minus 1 minus I plus 1 plus I minus 1 minus I plus 1 plus I, in that form, and then we will generalize I to the powers. So I to the power 6 is I square cube. I square is, or I cubes square, however I square is a negative 1. Negative 1 cube. Negative 1 cube, negative to the power odd is negative, so it is negative 1, and you see the number repeated. What about I to the power 7? I to the power 7 is I to the power 6 times I to the power 6 is negative 1, and what is I? Okay, this will, we can go for I to the power 4 times I to the power 3. I to the power 4 is plus 1. And I to the power 3 is negative I. 1 into negative I is negative I. So I to the power 7 is same as I to the power negative I. Now you see the symmetry here. I square onwards, every next exponent of I, how it goes? minus 1 or negative 1, negative I, positive 1, positive I, once again negative 1, negative I. That means the cycle is repeating after I5. So here this part will be used for generalization. So this is about positive exponents or powers of I. Now we'll go for negative exponents of I. For negative exponent of I, we'll begin with I to the power negative 1. I to the power negative 1, first of all, I to the power positive 1 is root over of negative 1. I to the power negative 1 is what? It is 1 by I. Imaginary number in the denominator is not permitted. So what we'll do is we'll multiply I to the numerator and denominator to simplify. 1 into I is I into I is I square, but I square is negative 1. So it is I upon negative 1. Multiplying minus 1 to the numerator and denominator, we will get this as negative I. So I to the power negative 1 is a negative I. So this is one of the statements. Then what about I to the power negative 2? It is 1 by I square. I square is negative 1. So 1 by negative 1 is a negative 1. Now you see some symmetry is coming up here. Now we'll go for I to the power negative 3. That is a 1 by I cube. 1 by I cube is negative I. So this is overall negative 1 by I. 1 by I is I inverse, which is negative I. So negative of negative is positive I. This is 1 by I to the power 4. I to the power 4 is 1. So 1 by 1 is 1. Now here also you see the symmetry. Based on this symmetry, we will generalize or will write a general formula for the powers of iota. I to the power 4 times k. K is any integer. K belongs to the set of integers. So I to the power 4k is 1. I to the power 4k plus 1. The next exponent of I to the power 4k is I to the power 4k plus 2. Its next is negative 1, and I to the power 4k plus 3 is a negative I. This is how when we derived the terms, we were getting 1I minus 1 minus I. Again the same sequence were repeating. So powers of iota, remember that I to the power 4k is a 1, I to the power 4k plus 1 is I to the power 4k plus 2 is a negative 1, I to the power 4k plus 3 is negative I.